in educational games and then moved to the corporate space designing for virtual reality training. And I am also a co-host of XR and LXD. Nice to meet you all. And I think I know most of you.
Yeah, came in too. And by the way, Tristia, your avatar came in so badass.
I know.
Yeah, I love your
gosh.
avatar.
Awesome.
That outfit
Thank you.
is rad.
I figured I should go with something that I would not have the confidence to wear in real life.
The sandwich.
Oh my
god. Everyone had the sandwich.
Tristia and Lauren.
Oh,
but
okay.
are you available, Tristia, or are you still getting things set up?
Hey, sorry about that, guys. Yeah, my for some reason my microphone is always set weird when I enter spatial. Sorry for being a little late. I was tied up with something. But thank you for the outfit props. I thought I should don something in the metaverse that I probably would not have the confidence to pull off in real life. But so thank you everybody for joining. I'm Tristia. I'm one of the co-hosts of XR and LXD, and today we have Tailspin's Kristin Torrence presenting on VR storyboarding today. So did everybody get a chance to introduce? I'm sorry I missed that.
Oh yeah, we did, but you need more
Awesome.
time, Kristin, to get
okay. I think I have it. I just need to find out where it is. There you go. I will get situated and pull it up. I know that's a screen right there. Can I pull it up there?
Can we move out of the way? Yeah, I'm going to get out of the way.
There we go. And let's make that.
All right. I also see Lauren. I don't know. I see Lauren here as well. Lauren, did you want to take a moment to introduce yourself?
Hey, Lauren. Here you go.
Hey there.
The talking sandwich.
Can you hear me okay?
Yeah. Yeah.
Oh, okay. Yeah. I don't know. Are we introducing ourselves in any particular way?
Just introduce whatever you feel like sharing.
Freeform. Okay. Yeah. This is my second time actually attending the meetup. I'm learning experience designer. I'm working right now at Meta. Prior to that, I was working at a startup, and we're just trying to create our own content for XR. So anyone who wanted to create like courses in XR, working on branded content. But yeah, and I'm in Oregon.
Oh, cool. We have some other folks in Oregon here, don't we?
I'm in Oregon. Hey, Lauren.
Who is it? Is it Tristia?
Yeah, this is
in Oregon.
I am.
Tristia.
Sorry, maybe my audio was a little bit messed up there. Sorry. Can you guys hear me okay now?
Yeah.
Mm-hmm. Cool. Yeah, I'm in Corvallis, Oregon, so kind of central.
Oh, yeah,
west.
Me too.
Oh, cool. Like you're in Corvallis, really?
Yeah.
It's such a small town. I was like, wait, what? Crazy.
I used to work at Oregon State University. So
awesome.
That's how, because Corvallis is such a small place, so it's like, why would you come here?
For sure, yeah. I worked there for a whole 2 months, but yeah, here for other reasons. But yeah, we should totally connect on Slack and go grab a coffee or something sometime and
yeah, sure,
talk VR.
Yeah,
not virtual.
Awesome.
Meet IRL.
Great, so I know it. in the physical world.
I know.
Don't
do that very much these days.
Yeah. What if you walk by each other and didn't know?
I know, right?
It's possible.
That's definitely possible. All right. I ended up putting it over here because I know that if I put it on the screen over there, it's probably a little difficult to see. All right. So I'm happy to talk through a storyboard that I created, and it's sort of a combination of a storyboard and a design document. And it's for really a mock design task. And you'll see that this mock design task is about mastering a micrometer. And we'll find out more what a micrometer is for those of you who don't know sort of really small measurement tools. But yeah, let's get started. Feel free, anytime during the presentation to ask questions, or feel free to shout them out. This is very casual conversation. Okay. All right, so for this small learning experience, the learning objectives were to learners will be able to correctly and consistently operate a micrometer and its parts, and we'll learn what those parts are. And then here I've also aligned what I call key learning points, and these are essentially actions that we'll see learners complete in the virtual reality task that are aligned to that learning objective. So they're almost like operationalized for what is visible in the VR space. And then the second learning objective is learners will be able to accurately read and interpret precise micrometer measurements without error. And we'll see that what that means is accurate barrel reading, accurate thimble reading, and calculation of micron measurement. So the learner for this particular design task, we're calling him David, and he's 18 years old. We have like a sort of a typical learner persona for him and sort of the day in his life. Some assumptions we're making about David are that he's between the ages of 18 and 20, has no prior experience with the micrometer. So this is a very introductory task. No previous exposure to VR. And so a lot of tutorials are probably going to be needed to cater to his previous knowledge. But he does have a desire to explore trades, which is where this particular tool is used a lot, and then has a basic level of arithmetic skills. So can add 3 numbers mentally, and we'll see why knowing that will be important. So as I mentioned earlier, this is also sort of serves as a design document. We're going to have a virtual coach in this virtual reality space who will serve as sort of a guide, an instructional guide, someone who supports the learner throughout their learning journey and provides sort of remedial help and feedback along the way. And so one of the things that we also wanted to do was define who that virtual coach is. And so we created a virtual coach persona. We named him Eddie. Got some just like a sort of a description of who Eddie is as a person, as if so we can bring this virtual coach to life, and some voice direction. And what purpose does this virtual coach serve? And so there are 3 that are outlined here. So sets the context of the module. So he serves to, introduce himself, introduce learners to the tasks, provides measurement tasks. So gives learners the actual tasks, defines that in a very explicit way. So learners know what to do, and then also providing feedback and guidance. Before approaching the actual virtual reality design, one of the things that I did was outline anticipated learner mistakes. So, what could learners do wrong? And this was sort of an exploration of, we want to design for micrometer mastery, but what does it look like for when learners make mistakes along the way? And how do we then, so defining these first really helped identify what sort of corrective feedback we would then have to provide. So object properties. So the micrometer is this little object here. It serves to measure really small and difficult objects to measure. So that object, that 3D object that will be in the virtual space, it will have some physics assigned to it. So some things that could happen to the micrometer is that it could be picked up and it could be put down. When it's grasped, it could be, let's see, it collides with things, right? Like we can't just, it won't pass through other objects in the field. So sort of defining things like that is really important. In terms of haptic feedback that this particular object might trigger, one of the things I thought would be interesting to note here, and this serves as a design document, but design documents, are sort of living documents. So this provides a blueprint, and then through collaboration with like UI designers, experienced designers, and devs, we would then further refine this. But this would then, it's good to have sort of a draft or idea of what some of this stuff might be to start that conversation. So in terms of haptic feedback, when a micrometer collides with another object, we might have some sort of like haptic like vibration. And then when the spindle is this this tiny like output of outshooting of the micrometer, when that approaches the target range, haptics sort of get stronger to illustrate tension due to high pressure and tighter turning. Actually, I think now that I read that, the spindle is this turning thing that you have to turn with your thumb. Sorry, it's been a while since I've gone through this storyboard, so I kind of forget exactly all the parts of the micrometer.
Excuse me. When you refer to target range, are you referring to the object that is measured?
Yes.
Or
correct.
are you referring? Okay.
I'm referring to the object that's measured, because so the way the micrometer works is that there's this little metal outshooting, and by turning your thumb, like I think up clockwise, counterclockwise, to the right, turning your thumb to the right, this outshooting gets, it extends closer to this. And so the closer you get, so the closer that is grasping, let's say it's about to, like we want to grasp or measure the diameter of this round cylindrical tube. So the closer that this end gets to the tube, and it kind of like clasps it in the middle, really the more tension you'll feel on the spindle thumb. So that was just an idea. Some sound effects would be, if the micrometer clangs, like if we bang the micrometer against the other objects in the environment, it might make a clanging sound. And so that's probably a sound effect we'll need to look for. Some soft metal touching sound effects, and then maybe some turning sound effects if the thimble makes some noise. So just some like object properties that were helpful to think through. And then thinking about, so for this particular design task, I thought it would be really important for replayability, especially because, if we really want to master using micrometer, we want to use it in a number of different scenarios, measuring a variety of different objects. So how do we design for that? And how do we design enough different tasks so that when learners come in, they feel like they're getting a unique experience every time? So the idea was to have for each of the levels 15 different objects in a space that could be measured. And for each of those objects, have 4 different parts that could be measured. So there's a lot of permutations there. But when you load each playthrough, they're randomly selected. So it randomly selects only 3 permutations for your challenge. And that way it felt like, that there was enough permutations there for variability and variety. Provided some art direction. So these are just images that I got from Unsplash. But I was thinking, this is a tool that could be used in a variety of different verticals. So maybe we're trying to use this tool in a number of ways, in a number of different, industries. And so level 1 is in the auto shop, level 2 is in the machinery yard, level 3 is in the aviation factory. And so just providing some visual direction as to what that might look like. And then some UI guidance meters. And you probably don't know too much about how a micrometer works, but things that I thought would be really important in terms of learners being able to accurately measure things with a micrometer, and how do we get them to do that? And so if you think about, there's an object that's being measured, so we'll call that a target object, and then there's the micrometer, and the micrometer needs to be positioned in a specific way to that target object, and it also needs to clasp the target object with the right amount of pressure between I think it's called the anvil and the spindle, now that I think about it. And it can't be too tight, or else the reading is incorrect, but it can't be too loose. So it just needs to be just right. So 2 guidance meters that I thought would be interesting would be to have a placement meter, so to help guide the learners of correct hand placement between placing the micrometer to the target object, and then the pressure meter, which would guide the learners in achieving the correct amount of pressure between the spindle and the anvil for that correct measurement. These are just some UI elements. And then some interactive signals, right? So how do learners know that things in the environment are able to be interacted with? And so one of the things, as you probably saw in a previous image, the micrometer is actually really, really tiny, and so are these little measurements. And so for someone to be able to read that, especially the reading in virtual reality, it would be really helpful to have that blown up or magnified in a certain way. And so it felt like using this scale function would be helpful, so learners can see the numbers up close, and then sort of just a highlight shader to know which objects you can measure in the environment. And then some other sort of UI elements, thinking that one of the things is how do we know a learner has a real intention to measure something? How do we know where they're not just sort of walking around with the micrometer, and because there's a certain amount of assumptions that we need to make in terms of knowing what to grade or what to assess with their performance, right? So one of the things I thought would be really helpful was to define a target object zone and have that be very visible to the learners so they know if you're trying to measure within the target object zone, then your performance there sort of counts, right? But if you're outside of the object zone, maybe you're just sort of fiddling with it in your hands, sort of walking around, sort of observing it or inspecting it, that behavior should not be counted against for, right? Like you shouldn't be penalized for inspecting the tool that you're supposed to be using or playing around with it and whatnot. And so one of the things that would be important is when learners are outside the target object zone, they know that they're not being assessed. But when they are intentionally going into the target object zone with the target object and the micrometer in their hands and attempting to measure, that performance is then going to be counted for. And then some additional reference supports. You'll see that later on that there are different levels, and in each level wanted to provide a number of sort of reference support material. Oh wait, I guess, yeah, reference support material is only visible in some of the levels. Primarily level 1, and then it looks like they're disabled for level 2B, which is attract observation, and then level 3, which is really the boss level of using the micrometer. So, but reference support really aims to provide the learner with a visual aid of how to, like, sort of reminding them how to use the micrometer if they are experiencing some trouble. One of the things also very helpful in your design documentation is outlining what the controllers are supposed to be doing and really the function of them as learners are interacting in the virtual reality space. You can see here with the joystick, you can turn left to right, to rotate the thimble. A is transporting toward a measurable object. Using the grip button to grasp, pick up, and hold objects, and then the trigger button to select options. And we'll see we have some buttons in the experience that learners are able to press. Wrote out some assumptions. So remember, this is sort of just a mock design task, but didn't feel comfortable not outlining these assumptions just because I felt like as I was designing, this was meant to be set within a larger VR experience. So this experience assumes the micrometer is a 15-minute module, part of a larger tool exploration experience. So assuming that the following has happened and thus is not covered in this design document. So the learner has played through an introduction of how to properly adjust the headset, controllers for their function and comfort. Module selection screens have already been displayed to the learner, and then the learner has already chosen to enter this micrometer learning experience. So let's take a look at what an overview of this experience looks like and what that logic flow chart looks like. So for a first-time learner, they will start the experience and begin at level 1 in the auto shop. And subsequent logins, right, they can leave and they can come back. Subsequent logins, they will be able to choose, I think, going back to level 1 or going to level 2. And then returning users will likely skip level 1, go directly to level 2 or level 3. So you start, there's 3 levels, and then the end of the experience. But remember, this is meant to be replayable, so we always sort of circle back. So here's a snapshot of the 3 different levels that were designed. And you'll see that they increase in difficulty as, you know, in an effort to properly scaffold the learners throughout this experience. So in level 1, it takes place in the auto shop. Just a reminder, it'll be 4 to 5 minutes long. So you meet your coach, Eddie, if we can remember Eddie. He teaches you about a micrometer, models how to use it, and then you're prompted to practice using the micrometer by measuring objects. And the task here is that the learner must measure 2 objects to achieve the exact measurement as the expert digital coach, who has predefined the measurements for that object. The first in the measurement task is tutorialize with controller guidance. And then instructional scaffolds that are in level 1 are that they're the tutorialization by the digital coach. There's going to be those guidance meters that we saw, sounds and virtual effects. Digital coach support, so that means he'll vocalize feedback to help you improve your performance if you're not getting it. And then measurement input and automatic addition. So we'll see what this looks like later, but that means that the learner does not have to do that addition or that arithmetic on their own. That would automatically be calculated. In level 2, this is sort of a more advanced experience, medium difficulty. Eddie takes you on a field trip to see his friends in the machinery yard. You're free to roam around and take measurements, and you're entrusted to submit measurements for a business report. So the learner must submit 3 measurements for a tracked observation, but this particular level, you can opt to have your measurement tracked. So you can go to an object, and you can practice taking measurements on that object as many times as you'd like. But it's not until you click track my submission or track my measurement that measurement will then be tracked. And so this provides learners with enough flexibility and practice to be able to sort of practice on their own, get the hang of it, do that muscle movement, but then opt in for being assessed. So that happens 3 times. And then the aviation factory, before we go there, guidance meters. So we'll have those same guidance meters, but only during the practice. When you opt to be assessed, those guidance meters will disappear because this is now an assessment. And then in level 3, the aviation factory takes place in the context of, there's going to be an inspection and you need to take some measurements. And so the learner must submit 2 measurements within a specific time period. There's going to be a countdown timer, and the learners must take those measurements, and those measurements will be assessed. This is sort of like a boss level, meant to be like a summative evaluation of the learner's skill. Again, meant to be replayable so they can always see their results, go back to practice in the machinery yard level 2 as much as they want, and then go back to level 3. So that was just sort of a snapshot of what that experience looks like. I won't walk through this entire sort of workflow, but this is essentially what only that level 1 will look like. So it's sort of a stage gate flow. So you'll see that once learners complete, it's somewhat linear, I guess, or at least level 1 is for sure. So there's like 3 different gates here. Each of these are the behaviors that learners will need to complete, and then this gray is UI elements, and then the text in the black here is let's see. Oh, control tutorialization, right? Because this is still level 1, and we want to introduce learners to how to use some of the controls that they're going to be continuously using. And I'm happy to provide this whole slide deck, or I think it's a PDF, in the Slack channel. But so you'll be able to see a closer look at what all of this looks like. But we'll just continue to see what the rest of these levels look like. So here's another flow chart right? And this is simply of level 2. And you can see here that there's really 3 different tasks, right? Because there's 3 things that the learner is measuring. They're nearly the same like workflows, but there's 3 different objects that need to be measured. And you'll see here that there are 2 different sort of so there's a sandbox practice, right? Remember I said that in level 2 you could practice for as long as you'd like measuring the object, and then if you choose to opt for a tracked observation, then you follow this sort of flow here. And then here's level 3. You start, you measure 2 things, and then you exit. So this is sort of just just a flow chart of what the learner will experience. Personally, I found flowcharts very effective in communicating to really across teams of what should be happening in an experience. I used Miro to create this flowchart.
When I made the scrambled eggs this morning, I made it for both of us.
Also part of this design document are measurements that I thought would be worthwhile to take, right? So there you can see all the different measurements, whether they're summative, formative, or sort of just analytic type measurements. So you can see here that the only summative measurement in this whole module occurs in level 3. There is formative measures throughout the entire experience, as well as analytics. It's always really helpful to track some analytics on your experience to just sort of, ensure that learners are progressing through as expected, and then also really helps you to iterate if you are seeing behaviors by learners that are that you did not design for, let's say. And then if you thought it would be helpful to have results screens within the app, within each of the levels, and you'll see here exactly what those result screens will depict. So here's the storyboard portion. And I know that was like a lot of upfront information about the experience, but here's what like a sample storyboard for this experience would look like. So level 1 is the introduction to the virtual coach. And you'll see here, I actually numbered them. And you'll see that these numbers correspond to each of the coded squares inside the flow charts to, for continuity and easy reference. So the learner is introduced to the micrometer using this diagram resource by the virtual coach. The virtual coach will model how to use a micrometer. The learner will then navigate to an object as prompted by the virtual coach using the controller. The learner will pick up the micrometer. As you can see here, I don't have really a full-on 3D representation of the entire virtual environment, but I'm providing enough in the storyboard so that, whoever's reading the storyboard gets a pretty good idea of what is happening. I think you could go as detailed or as not detailed as you want, but for storyboards, I kind of like to like it so that, really you're conveying as much information as you need to, so you're not spending really too much time on the storyboards. Next, the learner places the micrometer in proximity to the item to be measured, and you can see here on the controllers those grips. That's where the little circles on the micrometer, that's where the learner will be gripping the micrometer. This is obviously not to scale, but it's just for reference. And then here, reference to the guidance meters that we mentioned earlier. Learner turns the thimble to adjust the spindle, and they do that by using the joystick, turning it left and right. The learner then carefully removes the micrometer off the object because now that distance between the anvil and spindle is the exact distance of the target object's diameter. Then the learner clicks the button Calculate Microns, the big button right there, using the trigger finger, or sorry, the trigger button. The learner can then magnify what the micrometer looks like, or at least the measurement, to get an up-close view of what is measurable, or what really the measurement steps on the micrometer. And then the learner manually enters the measurements in the input area. So you can see here, the learner can click the up and down button to insert the barrel and thimble readings, and then it will automatically calculate the number of microns, or the micron amount. So you might remember to sort of scaffold for level 1, wanted this to be an automatic calculation, but in more advanced levels, the learner will need to calculate that manually in their head. They will submit the micron calculation, and then if those are accepted, then the learner will continue. In level 1, they have 3 things they need to measure, and then once they completed that, then they proceed on to level 2. So in level 2, the machinery yard, the learner navigates one of 3 possible items in the environment. So we'll just see one of those. Which mode do you want to play, right? Remember there was 2 different modes. There was a sandbox practice, where you can freely measure the object as many times as you'd like, or there's a tracked observation where you will then be graded on your performance. So the learner sort of does the same exact process of, and here we're using just that, at least for the storyboard, we're using the same exact object. In a machinery yard, the object that is in the machinery yard may look very different than the object that is in the auto shop. And we will continue. Okay, now we are in a tracked observation. So the difference between the sandbox practice for this step and the tracked observation is that the learners will need to enter this number themselves without entering exactly what the barrel reading is, entering what the thimble reading is, and having it automatically calculated. The learner will need to submit and calculate the microns themselves and then submit them. They'll be asked to confirm the submission, and this is the grade, or the amount of microns they will be then graded on. And then level 3, which again was the boss level. This level, as you can remember, has no supports. So they're just going into this environment, and it's sort of high pressure. They're under a time limit, and then they need to measure 2 items within the environment. And again, it's sort of the same steps here. The only difference is that when learners are submitting, they then get a results screen that tells them about their performance on these 2 measurements. And then finally, measuring learning. This is sort of outside of this learning experience, thinking about this micrometer mastery as it's implemented in the real world. How would we then measure learning transfer? we could do it in a number of different ways. There are 3 ways outlined here, as well as their pros and cons. So really, I thought it was really good for to include this sort of thing in a design document, so we know, because we're always designing for actual behavior change on the job, right? And so we want to be able to measure the efficacy of our solutions. So having a sort of a plan to do that is really helpful. Oh, and then there's some references. So that was actually my whole design document for this mock learning task. Are there any questions? No, I've been talking for a long time. Anything you want me to go back to?
I have a question. How long did it take you to do, I guess, the whole design doc creation?
Sure. I made this within a week. Yeah, on and off a couple of days. But yeah, this whole design task took about a week.
And is it like the same formula with each project, or is it just that's targeted towards this particular project?
Yeah, that's a really great question. So I guess this particular design was really just targeted toward the teaching and assessment of this particular tool. I can imagine, this teaching about how to use a tool is sort of a very simple, I guess, use case, but I think it's transferable to a lot of other tools, right? But there might be cases where it's very context specific or vertical specific, right? So maybe using like something like a manifold gauge in a car might be very different than using a manifold gauge in something like an HVAC system. And so I can imagine that when designing for something like that, that context would really come into play. And here, context was only, I guess, minimally into play, because it was more about the practice and allowing for practice versus like actual usage, like, because of a micrometer is simply used to measure, but it's not really a tool to like fix things, or it doesn't really have like a power to it in terms of like what other tools might be, like a drill, or some other more complex tools that might require sort of a more complex design and maybe more context around its use.
You don't suppose that teaching soft skills would be harder in virtual reality, do you? Do you think that the method that the design document we have here would look very different if it was teaching something like a soft skill?
Yeah, I would assume so, because this, something like a soft, I think at core, so let me go back to like some of the earlier, so things like inexperienced measures and results screen context, that could be applicable to soft skills. Using flowcharts could definitely be applicable to creating soft skill modules. Controls, obviously. Thinking about replayability, haptics and object properties, maybe not so much unless the soft skills is combined with some other object-based learning. But identifying things like anticipated learner mistakes, identifying, let's go back to the very beginning, learning objectives and key learning points, like things and actions and behaviors that we're looking for learners to exhibit in the virtual reality space. Like that is all definitely very transferable. So instead of identifying object properties, maybe you're identifying other characters in the virtual reality environment that the learner is interacting with, right? And maybe it's about instead of defining, and it could be more work around designing digital coach personas, right? If they're going to have a virtual reality coach inside the experience, or, really outlining what the scenario, the context of the scenario, like the conversational scenario might be for a soft skills training. So there's definitely a lot of parallels, but things like soft skills versus hard skills will have some nuances just based on the nature of the objects in the environment. And in this case, I'm also including virtual humans as like NPC virtual humans as objects in the environment.
You had a page that had pros and cons. Are those based on research trends, or is it something that's predicted that you think would be a pro or a con?
Yeah, those are, I know what you're talking about. So those were the, how we are going to measure the learning transfer of this, efficacy of this learning solution. Pros and cons. These are, I think, a combination of like experience, but also like research. So things like a structured observation, evidence-based, right? That's empirical, highly valid and reliable. However, structured observations are very time-consuming. It requires a lot of human resources to be able to do something like that, and expert evaluators. Also probably requires expert instrumentation and instrumentation development. So yeah, things like that. I think there's pros, and then there's also some limitations depending on like how your approach is, or your measurement methodology for efficacy.
Kristin? Oh, sorry, somebody.
Go ahead, Anil.
Okay. Yeah, thank you. This is very comprehensive, and you briefly mentioned about the analytics part. So I'm curious if what sort of solution is out there. Maybe you're using at your own company, like Tailspin. Is XAPI still a thing in VR, or is there like different analytics tools that are being used to actually assess the learning?
Yeah. So I think XAPI is absolutely still a viable tool, because XAPI, through what is called the game-based learning library, is compatible with Unity. And so you could track Unity behaviors, or like behaviors of learners in a virtual reality environment using a Unity engine, either using XAPI, and use it will. I personally haven't implemented that before, but I know it's been done, especially because there's a lot of educational games who do use that method. So and again, a lot of virtual reality is built inside game engines, and so the game industry, especially the educational game industry, is actually more ahead of us in terms of tracking learning and tracking players' behaviors, and then being able to infer learners' proficiencies based off of that data. And I know that one of the ways, in at least the research that I've read, was they took Unity. They either took log data from the game engine or used the game-based learning library. It's like a library, but it essentially utilizes XAPI, took that data, put it in a learning record store, and then we're able to analyze that data. I hope that was helpful.
So, Kristin, were you, in this one, of course, it was it sounded like everything was asynchronous, right? The coach was truly just a programmed voice. Is that right?
Correct, yes. Mm-hmm.
So what kinds of feedback would they be giving? Is it very specific, or is it more like, hey, great job, you got it, you nailed it, or maybe not quite? How specific do you usually try to get so it feels realistic?
That's a really great question. I like to get pretty specific so they know exactly what to correct. But have those triggers be like, and if it's not very specific, things like if they've done something well, you don't really need to call out that they've done it well every time they've done something correctly. If the learner is struggling for a number of times, and I guess I don't have it in this copy. There are ways to trigger feedback, right? So I guess maybe there's some quotes here by like example quotes by the digital coach. For example, you twisted the spindle a little too tight. Try adjusting it so it's not clamped onto the object. And this might trigger if the learner, went too far in you spinning the spindle, and so the object is actually like stuck inside the micrometer, and maybe they went too far on the pressure gauge and they weren't reading the gauge really well. So having very specific feedback, I think, is really important, as long as it's time, and it needs to be timely to that learner mistake, right? Like the learner can't make that mistake and, like maybe a couple of actions later, then they get the feedback. Like certain mistakes, and I think that's why, we outline the mistakes here. Each of these mistakes should trigger some verbal or like voiceover feedback by the virtual coach, or it might not be like voiceover feedback right away. It could be a sound effect, right? And say like, to notify the learner, like, hey, maybe that's not quite right. Try again.
And when they hear from the coach, are they seeing his face talking to them, or is he just an audible voice at that point?
I didn't really go that far in this, but I had imagined that he would just be, and he might just be a picture, or he could be an actual virtual human. But in this storyboard, I just imagined him as a little picture, and then maybe there's like some vocal, animation with like sound, those little like a sound symbol, so that the virtual coach is talking.
That's very good. I like it.
I was gonna chip in that for the feedback stuff, it's so funny because at Transfer we make things that are very similar to this. I think you've even designed something even more comprehensive than what we actually make. But as far as the feedback from the coach, it is right now, at least the way that we are working, it is the instructional designer's job to think about what constitutes a correct action. Like, have they correctly done this action? And if so, give that correct feedback. And it doesn't have to be, the coach saying, you did it, great job, for like just hitting a nail or something.
Right.
It doesn't have to be that over the top, but you can definitely have like a little chime that always chimes when they do the right thing. And actually, the way our sims are set up, the trainee cannot move forward until they do the correct thing, because just programmatically, that's just the simplest way is to set it up. So similar to like an e-learning, where in the e-learning, they have their, whatever the task is you're asking them to do in the e-learning, and if they hit that submit button, they're going to get feedback, and they aren't allowed to pass, right, until they do it correctly. So they're, and it is supported by VO. That's the other thing, is to think about these things ahead of time, because in the production cycle, you have to record the voiceover of what's correct, and if they're doing it incorrect, how are you giving that feedback? because all of that has to be produced before you can actually build the simulation. So all of that attention to detail is definitely something I find you really have to think about in VR way more than in e-learning, because in e-learning you can kind of fix things on the fly because you know you're usually a team of one or two maybe, but in VR you have to think about all those things first and then have other people actually build it.
Yeah, totally. And I know you mentioned, some of your experiences are like fairly linear. You can see I designed this experience. It's technically fairly linear as well. They need to be able to accomplish and do things correctly before moving on and unlocking a new gate. Any other questions? I hope this was helpful.
Yes, it's very helpful. I like that it's designed well too.
Yeah, this is great.
And I'll be sure to share this. Thanks, Anil. I'll be sure to share this in the Meetups channel as a reference everyone could have and dissect more. And I know that this link, I'll be sharing a PDF, but this link is active, so you'll be able to really read all of these images closer up.
So you call this a storyboard in the world of VR, and then is there some additional design document that goes, there must be something else that goes on after that you hand to developers, right?
I'm sort of calling this a combination design document plus storyboard. It doesn't really have absolutely everything. I would say the storyboard starts over here. Starts with this. But everything before this is more like design documentation.
I was also going to say, Kristin, that at the end when you had what Veronica pointed out, the ways of assessing in the real world, I thought that was really interesting because I know we don't do it at Transfer, and I don't know if I don't know enough about other companies who are developing this type of stuff to know, but like essentially what we design at Transfer is supplemental. So even if we were to have, let's say we developed a simulation about using micrometer, I don't even know that the aim of that simulation necessarily would be mastery, because what we're creating is usually supplemental to like an in-person training. So there's not a lot of pressure on our product to achieve that level of mastery. But I think that's interesting if there eventually one day would be some sort of VR credentialing program out there, because I don't think one exists yet. I don't know that the technology is good enough to say you can get credentialed in VR, but still interesting to think about, like what are some supplemental to our material. So like what job aids essentially could we produce along with our VR simulations, if that makes sense, like going back to paper, like we're selling the VR simulation, but we're also giving you like a workbook or, something, an evaluation method or something that we can also provide that additional value. I don't know if the people are doing that out there in the world or not. We aren't doing it at Transfer, but I think it's definitely an interesting idea that could provide more value to people who are using these simulations.
Yeah, absolutely. And, I think even if you're not implementing, like a company is not implementing this and then using these methods, as designers who create these, we also want to know that our solutions are working. So we might want to run a small pilot, right, with, a sample of learners, put them through this experience, evaluate them in some way, and then probably tailor our learning solution based off how effective, our learners are, whether they're producing favorable results or not, and also probably based on some additional interviews about their experience and stuff. But, I think a lot of VR right now is very waterfall. It'd be really great if it were iterative. I know it's kind of expensive. It's definitely expensive, but just want to reiterate that hopefully one day we'll be more iterative in our learning, design, and development of VR solutions. So I'm really sorry. I have to drop off. I have a call at 6:15 for something. But I wanted to thank everyone for being here and being curious about this design document and storyboard and asking really awesome questions. If anyone has any follow-up questions, feel free to ping me in the Slack channel. I'm available, or if anyone wants to chat more, just let me know. But if I don't speak to anyone before the weekend, I hope everyone has a wonderful 4th.
Thank you so much, Kristin. Thank you.
Thank you.
And happy 4th, everyone.
Later.
That was awesome and very thorough. Really appreciate you sharing your experience and that design document and storyboard with us. That was absolutely fantastic. Thank you.
Yeah, thanks for having me.
Awesome. Well, since we're already a little bit over, I'm going to go ahead and drop off and stop the recording. If you guys want to hang out and chat with each other, you're more than welcome. Thank you again to everyone for showing up. Another successful and fantastic meetup.
Woo!
Thank you.
All right. Awesome. And Lauren, I'm going to send you a DM and we'll hook up later. Cool. Bye, everyone. Happy 4th. Have a great weekend.
Bye.
Yeah, bye.
Have a good weekend.
Happy
Great
4th.
4th of July.
Bye.
Wait, whoever can hear me, Anil? Veronica?
I'm still here.
Yeah.
How are you moving your bodies? Like, people are putting their hands on their hips and clapping. Is that through Oculus?
Oh, do you not have a headset?
I think
I
for
don't have a
most of the
headset.
body movements, yeah, you need a headset for like the clapping and
Yeah.
moving of the hands. Your hands kind of like move a little bit automatically if you're talking. Like your avatar will just do that.
It's just your girl.
Hey.
But
And-
you can do some things with the keyboard.
Yeah,
though.
there's
I think,
something-
Is it like by pressing 1, 2, 3? Try pressing some numbers like 1, 2, 3 and stuff like that. Does that there you go.
Oh my goodness.
See,
Yeah,
that's what it
yeah,
is. And
yeah.
you can dance. Isn't that cool? See, we can only dance like our real bodies, but when you have the keyboard, you can do some cool stuff. See, that's fun.
That's cool.
I was so happy to just try and get in
I
here as
didn't do
quickly as
that.
possible.
It's
I
good
didn't
that you
see
made
all that.
it. Yeah, and I mean, I don't know if you do have a headset, but if you have a headset, the feeling of it for you is more immersive because you feel like you're actually standing in the room. But when you don't have a headset, you could still totally enjoy yourself, right? You can have a cool dance party.
I love it.
Woohoo! Yeah, now we should have a dance party for real because we have a boombox and everything, right?
We gotta get a
Wait, but
DJ.
Veronica, do you have a headset, or are you just doing that with your keyboard?
I'm on the
I think she's just doing it with her keyboard.
I think
That must
we.
be
Yeah,
keyboard because the keyboard
it's
people
the
have really
keyboard.
cool moves. If you are headsetting, you could do like could do my own disco movement. Does that look like disco?
I wonder
Like
if
moving my
there's
hand.
some kind of like combination button press or something that can bring up some of those dance moves in on the headset. I don't know, because I don't
It
think
would
I
be
can
really-
pop and
it
lock
would
that
be
well
really
in real
good.
life.
I mean, I'm over here just having a good old time. I'm pop locking,
Right?
dropping, roboting. Oh yeah.
Yeah, roll it. So
Oh yeah.
I think we got to
Listen,
get Chris
that's
Marinick, our resident musician, to like DJ one of these events or something. It'd be cool.
Oh, that would be so cool.
That would be so fun. This year, your outfit is boss.
Thank you, thank you. I don't think I
love
would
it.
ever have the confidence to wear this in real life, but I am looking pretty fly, huh? Yeah.
Yes, you really are. I came in casual. Came in from a fresh workout. Yeah.
So that's all just a Ready Player Me outfit?
Yeah,
Kristin?
so if you go through Spatial's if you go through Spatial's thing, edit your character, edit your avatar, you have the choice of keeping their like weird photograph rendition of your face, or you can switch over entirely to the Ready Player Me character builder, which I think just works a little bit better. I don't know. I thought I looked a little bit strange and like out of proportion with the camera face. And so yeah, I just redid my avatar with their new Ready Player Me stuff, and the outfit choices on there are pretty awesome.
Oh, that's great. I might give that a try for the next month.
Yeah, it was fun to do. It's like, when you're playing a new game or RPG and you get to set up your character and like pick out all their things. It's, I don't know, that's like the most fun. That's the most fun part of the game, right? Like setting up your character.
And especially like you said, dressing up in something that you wouldn't normally wear.
Right. Yeah.
Yeah, that's
complete with facial tattoos
that's what Metaverse is for.
Exactly, Anil, right. That's what the metaverse is for, is like, bringing out the other sides of your personality. Gotta say, these shoes do make me feel more confident. Like, even just looking at them, I'm like, yeah, I'm on fire.
I know, I love them.
Those are like dragon shoes.
Yeah, they are pretty styling. I'm gonna turn around just to, look at that. They got flames coming off my heels. I love that.
it.
Yeah.
Oh.
Hot Wheels, I guess.
Yeah, Hot Wheels.
Right? I know. Oh my God, it does look like Hot Wheels. Oh, that's so funny.
Yes.
I keep accidentally moving that tree. I'm on desktop today.
Oh, is that you who was doing it?
Oh yeah,
I was wondering because like all the tree just like keeps on showing up and moving around the room.
I thought I locked it. I just
Was
locked
that
it.
from our original? Was the tree from the original setup?
It was.
Was that from the campfire?
Yes, it was. It was actually from the room before the campfire, the very original, the museum gallery room. And then we just kind of left it at the campfire scene because it was kind of neat. And then when I reset to this room, I thought it'd be neat to do something a little different this time, have a little different environment. They showed up in some really weird places, like just kind of floating in midair. So I had to reset them. But I guess I forgot to lock a few because if you don't lock, you can lock the object so that it's not, easy to mistakenly grab it. But I must have forgotten to do that.
So when you reset the room, Kristia, was it like you just start with a fresh environment, or is it somehow taking objects from your previous room and bringing them here?
I will show you, and we will go to the boardroom lounge.
Ooh.
Oh, there we go. This looks familiar. I think I have a room like this.
Where
this
we
is
going?
like their traditional.
Oh my goodness.
So you just change the environment. You, as the administrator, you just say change environment, and it puts us in a new place.
Yeah, it gives me a couple different options. Here we can go back to the campfire one. There's a couple of other ones. You can also upload your own custom environments. Here's an auditorium. I think we did the auditorium a little bit on one of the very first meetups.
Ooh, this is neat.
Yeah.
Mm-hmm.
I remember this. This is when we had a half body.
Yep. We only had half bodies back then. I feel like the legs are so natural that I almost like don't even remember having half body.
Do you have to sit down to actually be sitting on one of these things?
Hard to even remember that.
Like, am I standing or sitting? when I'm on this
You
little
are
pad?
standing right now, Kimberly.
I'm standing. Okay, so if I do this, am I sitting?
You're sitting, yeah. Now you're sitting.
Yeah.
That's so interesting. So it's like it's able to judge because of my headset where it is in relation to the floor. I love it.
How did you sit down?
If you click, if you're on the
sit down?
desktop, you
Click on
can
a chair?
click on a seat area, like one of the seat cushions, and a little green arrow thing will pop up, and you can,
Oh, you're sitting.
Sometimes. So I guess sometimes it's like just making me stand on them.
Hey, Leslie.
I told her about ideas.
All right, guys, I gotta head out,
like, you
but
left
thank
the
you
dance
again
party.
for showing up,
Okay.
and I'll see you guys again in a couple weeks. Have a good
This was
one.
awesome.
Thank you, Tristia.
Bye.
I'm waving.
Bye, everyone.
Bye.
I like that. It's hilarious.